Good morning, my name is Pamela Vasquez and my topic is Precision Ultralow Power High Side Current Sense. Introduction. Precision high side measurement of microamp currents requires a small value sense resistor and a low offset voltage amplifier. The zero drift amplifier has a maximum input offset voltage of just 5 volts and draws just 1.4A, making it a great choice for a building and complete ultra-low power precision high side current sense circuit. 0 point. A critical specification for a current sense solution is a 0 point, or equivalent error. Current at the input for the output produced when no sense current is present. The 0 point is generally determined by the input offset voltage of the amplifier divided by R sense.
Hello, and welcome to this edition of Amplitudes. My name is Kevin Schroeder, product marketer with Microchip Technologies Analog Division. This Amplitudes edition will cover the viewer-recommended topic of using amplifiers in current sensing applications. The need to closely monitor currents in today's electronics has increased over the years, as energy efficiency and safety have become major concerns. This video will focus specifically on the use of a shunt resistor to monitor current. For shunt-based current monitoring, the first question that must be addressed by a system designer is where to monitor the current. There are two basic options: high side and low side current monitoring. For high side current monitoring, the shunt resistor is placed between the power supply and the load, as shown here. For low side current monitoring, the shunt resistor is placed between the load and ground, as shown here. Both of these approaches have their pros and cons. High side current sensing has the benefit of being able to detect current-related faults, such as a short circuit or an open circuit that could affect the load. Also, with high side current sensing, the load can be referenced directly to ground, as we'll explore later. The main disadvantage of high side current sensing is that the common mode voltage is relatively high based on the supply voltage. Hence, a high common mode amplifier is required. As opposed to high side current sensing, on the low side, the common mode is referenced to ground. Hence, a cheaper, more readily available, low voltage amplifier can be used. As alluded to earlier, one disadvantage of low side current sensing is that the shunt resistor is placed between the load and ground, which can cause ground loop issues since the load may not be at the exact same ground potential as the rest of the circuitry. As I mentioned earlier, for low side current monitoring, essentially any single supply, low voltage amplifier can work, as the common mode voltage is ground referenced. Selecting the best amplifier for this situation depends on price versus required performance, as the amplifier's offset voltage, offset drift, common mode and power supply rejection, and transient response may all be critical considerations. For high side current sensing, the amplifier must be able to support the higher common mode range, as well as handle any voltage transients that may occur on the power line. A system designer can again use a standard operational amplifier configured as a difference amplifier, as shown here. However, there are some limitations to this approach. First, the input resistance is relatively low, determined by the external resistors, not to mention that the input currents aren't matched, which will limit the common mode rejection. Speaking of which, the common mode rejection will be limited by how well matched are the resistors, which leads to subpar performance. Due to these limitations, amplifier manufacturers have created specialty amplifiers for high side current sensing, such as Microchip's PAC1921. These specialty amplifiers support high input common mode ranges, while the core still runs off of a lower voltage rail, such as 3 volts or 5 volts, which simplifies the interface with lower voltage microcontrollers. This specialty device also provides a digital interface, providing voltage, current, and power information. The PAC 1921 also supports an analog output for real-time data collection, making it an ideal solution for high-side current sensing. In summary, for shunt-based current sensing, the system designer has two basic choices, either high-side or low-side sensing, each with its own advantages and disadvantages. Which one is the best choice depends on the application. Thank you for joining me for this edition of Amplitudes. For more information, please visit www.microchip.com/linear. If you have a topic you would like reviewed in Amplitudes, please be sure to leave a comment below.
Supply current. In addition to the current consumed by the active components, an output current, I drive through M1, also supplied by B supply, is required, proportional to the output voltage, ranging from 208 from 1.0 volts output to 508 for a 2.5 volts output. Thus, the total supply current in addition to the iSense ranges from 2.58 to 780 amperes. Our drive is set at a 5 ohms for a reasonable ADC drive value. Input voltage range. In this architecture, the maximum supply is set by the maximum BDS that the PMO's output can withstand. The BSP is rated for 100 volts, so 90 volts it's an appropriate operating limit. Since the output of the circuit is a current, not a voltage, ground or lead offsets does not affect accuracy. Thus, long leads can be used between the outputs, allowing our sense to be located near the current being sensed, while our drive is near an ADC and other subsequent signal change stages.
Hi, my name is Sam Weinstein, and I'm the product manager for the CurrentSense family of parts here at Analog Devices. I'm extremely excited to tell you about our new AD8207, which is a breakthrough CurrentSense amplifier representing many years of technology advancements in this product category by ADI. This device features an unmatched combination of accuracy and robustness, ideal for PWM closed-loop current control in a variety of demanding applications. The zero-drift core and multi-pass temperature testing allows us to guarantee a 1 microvolt per degree C maximum offset drift specification, 8 times better than our previous best part, and a total maximum offset spec of only 400 microvolts over the entire operating range of -40 to 125 degrees C. The 8207 has the distinction of giving system designers the first zero-drift current sense to work with PWM common mode signals down to -4 and all the way up to 65 volts. The part can tolerate these large swings occurring in only tens of nanoseconds while maintaining accurate output. In designing this part, we focused on the 3 E's that are very important to safety-critical automotive, medical, and industrial applications: EMI, or electromagnetic interference, ESD, or electrostatic discharge, and EOS, electrical overstress. The 8207 includes EMI filters and underwent component-level EMI compliance testing, which can ease later board and system-level EMI qualification. The ability to withstand ESD is a common requirement for integrated circuits, and this device meets or exceeds all AEC-Q100 ESD requirements. EOS protection is also a key robustness feature, which is why the part is designed to survive input voltages from -25 to 75 volts. In safety-critical applications such as electric power steering, where current is monitored on 2 of the 3 motor phases, current sensing provides torque feedback and diagnostic control. A current sensor that drifts over temperature leads to real-world consequences, such as a stiff or shaky steering wheel. Another example is hydraulic valve control boards for heavy machinery, such as cranes and farming equipment. The 8207 temperature performance ensures that temperature effects are negated, especially since such equipment is intended for operation in climate extremes. Thank you for taking the time to learn about our newest best-in-class AD8207 current sense amplifier. For more information, please visit analog.com/AD8207.
Architecture. The LT reference, along with the bootstrap circuit composed of M2, R2, and D1, establishes a very low power isolated 3 volts rate that protects the LTC from seeing its absolute maximum supply voltage of 5.5 volts. Although a series resistance could suffice for establishing bias current, using transistor M2 allows for much higher overall supply voltage, while also limiting current consumption to a mere 280 amperes at the high end of the supply range.
Offers a variety of current sense resistors with different wattages, resistances, and sizes. Watch our previous podcast on current sense resistors for more details on our specialty current sense resistors. Ohmite's 10 series features a Kelvin configuration design. This configuration provides high accuracy, great temperature stability, and is available in values as low as 5 milliohms. For relatively high current requirements, Ohmite offers the 610 and 650 series 4-terminal bare element resistors. These feature a radial Kelvin configuration and PCB mounting capabilities. The 650 is able to carry 100 amps of continuous current, while the 610 can handle up to 32 amps. Ohmite's 14A series of axial-leaded current sense resistors now provide higher power densities and smaller package sizes. These resistors feature a high-temperature ceramic body for efficient heat transfer and are available down to 4 milliohms. Ohmite's LVC series, available in industry-standard sizes, offers low tolerance to improve accuracy and repeatability for current sense applications that require space-saving and cost-effective solutions. The LVC series is available in values as low as 10 milliohms. The non-inductive 3-piece welded element 60 series resistors offer a reliable, low-cost alternative to conventional current sense products. Features include low inductance, wire-wound performance, and flame-proof design. Ohmite's 60S series SMD bare metal element resistors are offered in 3 standard power ratings, with a resistance range from 2 milliohms to 8 milliohms in a standard 5% tolerance. Ohmite's WL series miniature molded axial-leaded wire-wound resistors use high-purity ceramic cores and wire, which are spot-welded by CNC machine tools to ensure total operational consistency throughout. The WL series is available down to 5 milliohms and 2 watts of power dissipation. Ohmite's 89 series high-performance axial-type resistors are able to withstand vibration, shock, and harsh environmental conditions. Resistance values down to 5 milliohms are available. The 89 series metal mite resistors are aluminum housed to maintain high stability during operation and provide heat sinking capabilities. To learn more about the many current sense resistors Ohmite offers, visit www.ohmite.com. Stay current with Ohmite news by following Ohmite on Twitter and Facebook.
Precision. The main source of ascertaining in the output of this circuit is noise, so filtering with large parallel capacitors is crucial to reduce noise, bandwidth, and thus the total integrated noise. With a 1.5 Hz output filter, The LTC adds about 2 bp to P low frequency input referent noise. Averaging the output over the longest possible duration further reduces error due to noise.
Hello, my name is Mitch Polonsky, and I'm the high-side current sensor product marketer in our analog division here at Microchip Technology. I'd like to introduce you to our PAC 1921, Microchip's high-side current sensor that features both an I2C compatible bus with a configurable analog output. The device is part of Microchip's high-side current sensor family. All of the members of the family are able to present power, current, and voltage over their I2C compatible bus. The PAC 1921, however, goes further by presenting power, current, or voltage information over a single analog output. The PAC 1921 is the world's first current sensor to present power, current, or voltage information over a single analog output, while also presenting the values over its digital interface. This allows the device to report complete information over the digital interface while presenting more immediate information over its analog output. This minimizes data latency. This analog output can be configured to present its full-scale voltage as 1, 1.5, 2, or 3 volts. In this manner, the PAC 1921 can be made compatible with different microcontrollers and ADCs. The output voltage range of 0 to 32 volts makes the PAC 1921 suitable for networking, industrial automation, power supplies, computing, and power distribution. In fact, with a scalable gain of 128 times for current measurement and 32 times for voltage, the device can measure light and heavy current loads while maintaining an accuracy of 1% over its entire power measurement range. Finally, to make the device more useful, it comes with a read integrate pin that can be used to measure continuous periods up to 2.9 seconds long. If used on multiple voltage rails, the measurements can be synchronized with the same GPIO pin. For development, Microchip offers the ADM 00592 evaluation board, which can be found at microchip.com/ADM00592. Thank you for taking the time to learn more about Microchip's PAC 1921, the world's first high-side current sensor with a compatible I2C interface and a configurable analog output. For additional information, review the product page at microchip.com/PAC 1921.
Finally, conclusion. The LTC's ultra-low input offset voltage, low offset and IBS and rail-to-layer input provide precise current measurements over the entire range of 100 amperes to 250 amperes. Its 2 amperes maximum supply current enables the circuit to run and far less than 280 amperes supply current for most of its operating range. Along with the LTC, thus low supply voltage requirements, the low supply current allows it to be powered from a voltage reference with a headroom to spare.
Microchip brings you another world first, this time in high-side current sensing. You know how most high-side current sensors just give you an analog output? Well, Microchip's PAC 1921 is different because it gives you a configurable analog output for power, current or voltage over a single pin, and a simultaneous power information output over a 2-wire digital bus. So, whilst the digital bus is giving you improved data and diagnostics for prototyping and characterization, the analog output is reducing your data latency for production. And the PAC 1921 is versatile too, because you can adjust the analog output to suit microcontroller inputs of 3 volt, 2, 1.5 or even 1 volt. That means you can use the PAC 1921 across a range of different microcontrollers. To discover more about this world first, check out the website today.
Thank you.